Okay, for our fourth example, we're going to move away from linear inequalities and go to something which is nonlinear. So we're going to graph the solution set to a nonlinear inequality x squared plus y squared is less than or equal to 9. Okay, and what you have here, and this is why we did some of the work that we did with our circles, this is a circle. Because the x squared and the y squared don't have any pluses or minuses on them, that means that the origin of that circle is at, the center of the circle is at 0, 0, so right there. And the outside part here tells me that we have a radius of the square root of 9, which is 3. So what that tells me is that I've got 1, 2, 3, 1, 2, 3. This is probably not going to be the best looking circle, but you'll get the idea. So I'm going to put a dot here because I know I've got a radius of 3 all the way around. Then I'm just going to try and make a circle that goes through those points to the best of my ability. And the other thing I want to look for is, is that symbol right there is the equal to symbol. So when I draw my circle, it will be a solid line circle. It's not going to have any dashes in it. So let's go ahead and see how well I can, or how badly I can mess up this circle. I'll stop doing that. Oh man, sorry about this. So let's see, we're going to have a circle. Oh, this looks much more like an ellipse, but you get the general idea. That's supposed to be a circle. Okay, so the idea is, just like before, it doesn't separate it into two half planes. It separates it to the inside of the circle and the outside of the circle. And we want to know what the solution to this thing is. Well, it should be relatively intuitive that it says x squared plus y squared is less than or equal to that 9. So we're probably thinking it's the inside of the circle, but let's go ahead and check it out. So what I'm going to do is I'm going to take a test point, just like we did before. I'm going to pick the origin. To me, that seems like the easiest point to pick. So if I test that point and it's true, everything inside the circle will be true. If I test that point and it's false, that means everything outside of the circle is going to be true. So that's the test point 0, 0. So we'll simply plug in 0 for x, 0 for y, and we'll see if we get a true or false statement. So 0 squared plus 0 squared, of course, is 0. And it says 0 is less than or equal to 9. Well, is that a true statement? Of course it is. 0 is less than or equal to 9. So that means the inside of the circle is our solution set. So everything in here gets shaded. And of course the biggest thing there was knowing the actual graph of the circle and then being able to test a point. Okay, everything that we've done so far has been non-system. Basically, it's just been one equation that we're trying to figure out the solution to the inequality. Well, now we're going to go ahead and graph a system. So now we're going to do a system of inequalities, and we'll start off with linear ones. To see what that looks like. System of linear inequalities. This means we're going to have two or more linear inequalities. So let's go ahead and write our system, which is going to be x minus y is less than 1. And then we'll have 2x plus 3y is greater than or equal to 12. Okay, and when we graph this, what that means is we have to graph both of those on the same graph. So let's start off with just graph the first one first. It makes the most sense. If we use our elimination method, if you cover up the y part on the top equation, you would just get x is less than 1. So x is 1 is your first intercept. If you cover up the x part, you're going to have negative y is equal to 1. So then if you divide both sides by a negative sign, you would get y is equal to negative 1. So there is my first 2 points of my top equation. Now in the top equation, there's no equal to symbol, so when I draw the line through those 2 points, the line will be dashed. And again, just do your best. Doesn't have to be perfect. And there's our first equation. That one is our x minus y is less than 1 equation. Alright, the second one. Again, I'm going to use the cover-up method to find my intercepts. I think it'll be the easiest. So if I cover up the 3y And again, I can just kind of do this to show you. If I get rid of the 3y and we solve it for x, we're going to divide both sides by 2, so we get that x equals 6. So let's go ahead and plot the 6. X equals 1, 2, 3, 4, 5, 6. So right about here. And then if I was to cover up the x part, I would divide both sides by 3 to solve for y, and we get that y equals 4. So we're going to have to go up to 1, 2, 3, 4. And this one does have an equal to symbol on it, so when we draw this line here will be a solid line. I'm not doing a very good job of keeping my hand steady when I draw the line there, but that's the general idea. So now what we have to do is, what you should see is you have 4 different sections, okay? I've got this section up here, I've got this section down here, I've got this section over here, and I've got this section over here. I've got 4 different sections that I actually have to test. Now I'm going to erase all those because we need to actually keep those free. But I've got 4 different sections that I need to test. Technically, you really only need to test 2 sections in order for this to work. So this is what we're going to do. We're going to figure out the solution to just the top equation, just the yellow line. Let's figure out what that would look like. Let's take a test point. Well, the test point, or the easiest test point, would be the origin. And remember, if I test the origin into the top equation and it's true, everything to the up and left of the yellow line is going to be good. If I test the origin and it's false, everything down and to the right is going to be good. So let's test the origin in the top equation. That would say that 0 minus 0 is less than 1, which is just 0 is less than 1. Well, 0 is less than 1 is false. That's not a good statement. That means that everything on the same side of the origin there is false, so we got to go to the other side of the yellow line. So I'm going to go ahead and shade everything over here. All of this is true for the yellow line, or for the yellow inequality. Well, that means that everything on the other side is false. So really, now that I'm looking at the blue line, I've only got 2 spaces left for me to check. Okay, I need to check something that's either up in here, or something that's down in here, one or the other. Again, I'm going to get rid of those just for a second. So let's test one point that's in that section right there. Well, I'm going to test something that's, again, that's relatively easy to test, and we're going to test it in the second equation. You have to use the second equation here. I'm going to test this point right here, because that is clearly on the same side of the yellow line, but it's going to be on one of the other sides of the blue line. In this case, it's below the blue line. So I'm going to test that point, and that point there is 2, 0. That's my test point. And I'm going to plug that into the second equation. So I'll have 2 times 2 plus 3 times 0 is greater than or equal to 12. We'll see what kind of a statement we get here. 2 times 2 is 4. 3 times 0 is 0, greater than or equal to 12. The statement says 4 is greater than or equal to 12. Once again, that is false. That is definitely not a true statement. So that tells me that everything below the blue line is not a solution. So everything above the blue line is a solution. All of this is a solution. But the important part is right here. This part right here is the overlapped section. That is the solution to our system of inequalities. It's where those 2 pieces overlap. So it's where pretty much it looks like a bunch of green scribble and stuff over there. That's the solution to your system of inequalities. All right, we've got 2 examples left in this section. Example 7, we're going to have the system. Y is greater than or equal to x squared minus 4. And then x minus y is x minus y is greater than or equal to 2. Okay, so again, we need to sketch those. So the first one is a parabola. We need to sketch the parabola. Okay, So if you remember how to find this stuff, and I'm not going to go back through all of it, this parabola has a vertex at the point 0, -4, which is down here. It has x-intercepts at 2 and -2, right there. And then I can kind of sketch my parabola that goes through those points, and remembering that a parabola looks something like this and goes on forever. And then the second equation is linear. Again, if I cover up the y, I'm going to get x equals 2. If I cover up the x, I'm going to get y equals -2. And that one is going to go like this. It's linear. Both of these were solid because of the fact that there's equal to symbols. So I've got a few different sections here to test. Now I've got a bunch of different sections. So the first thing and the easiest thing to do might be to test, well, it doesn't make any difference. It might be to test the line though. And then we're going to see what part we're going to be dealing with here. So let's test the line. Again, let's pick the origin. It's the easiest thing to pick. Let's pick 0, 0. We're going to do this for testing the line portion now. So if I plug 0 into the linear equation, I get 0 is greater than or equal to 2. Well, that's a false statement. So again, that is false, which means that everything below the green line is part of my solution. So let's shade everything below the green line. That's part of the solution. So now all we really have to do is we have to figure out, okay, is this going to be inside that between the green line and the little yellow bottom part of the parabola, or is it outside of it? So we just have to pick one value to pick, and technically we could still pick the origin, but let's pick a value that's actually in one of those areas. So I'm going to pick this value right here, and we're going to see whether that's true. If it is true, we'll shade the inside in between the green and the yellow. If it isn't, we're going to shade on the outside of the green and the yellow, so basically below the parabola. So let's go ahead and take a look. So we're going to plug that point. Well, that point is the point 0, -1, 2, 3, -3. So we're going to test the point 0, -3. So that means that y is -3. And remember, this is going into your parabola. And 0 is x. So we get -3 is greater than or equal to 0 minus 4, which is -4. Is -3 greater than or equal to -4? Yes, a smaller negative number is bigger than a larger negative number. So this is true, which means that everything on the inside of that little section right there is true. So we did that in yellow. So let's go ahead. Actually, we'll just do the whole thing in blue. So basically everything in here is your solution. That is your solution to this. Now you could have picked a different point and tested it, but again, I picked something inside. If I had picked something outside, it would have given me a false statement. In this case, it gave me a true statement. So there is your solution. All right, one more example to go. Okay, example 8. We're going to do a system of inequalities. The first inequality is x minus y is, let's go with less than 2. The second one will be -2 is less than or equal to x, which is less than 4. We haven't seen one like that yet. And then y is less than 3. So this one's interesting in the fact that we have more than just 2. As a matter of fact, we technically have 4 because that middle one can be broken up into 2 different inequalities. So let's go ahead and take a look at this. This would probably be one of the more involved ones because we have a lot of different graphs to put on here. Let's just go ahead and graph this. Let's graph the first one. X minus y equals 2. So if we cover up the y part, we get the x-intercept is 2. Covering up the x part, we get the y-intercept is -2. Okay, there is no equal to symbol, so this will be a dashed line through here. There's the x minus y is less than 2. We'll just put a blue dot there so that we know that that was the blue one. Okay, in green, first thing is I'm going to not even look at this part right here. I'm just going to take into account the first part of this. It says negative 2 is less than or equal to x. Another way of saying that is x is greater than or equal to 2 if you turn it around. So, negative 2. So I'm going to go to negative 2. I'm going to draw my vertical line. It does have an equal sign, so I'm going to make it a solid vertical line right there. Okay, that's the first part. Now I do have to take into account this one, so I'm going to eliminate or not look at this part. And I'm now just going to look at the part that says x is less than 4. So I'm going to go to where x is 4. And I'm going to draw my vertical line through that. Now this does not have an equal to symbol, so it will be dashed. All right, almost done. Now we have the y is less than 3, so we'll go ahead and put some green right there so that we know that those middle two were green. And then we've got the y is less than 3. So we're going to do that one in red. So we're just going to go to where y is 3. 1, 2, 3. And we're going to go ahead and put, in this case, it's a dashed line right through y equals 3. So what I have is I have a whole bunch of different sections here. Easiest thing to do is to do the ones that are really simple first. This thing says that the x part has to be in between the negative 2 and 4. So we're talking about in between the two green lines if we look at the second one. So we know we're only dealing with in between the two green lines. The y part on the bottom one, the red one, says that y has to be less than 3. So we're in between the two green lines and we're below the red line. So we know we're only talking about, I'm going to erase this, but we're only talking about this possible section right here. So what that means is we just have to figure out, are we above the blue line or are we below the blue line in that kind of that rectangular region? So that's all we have to figure out. So really what we have to do is check one point on either side of the blue line. Fortunately, we can use the origin. So let's use it. Let's use the origin. And the blue line was the top one. So we're going to plug in 0 and 0 and see what we get. Well, 0 minus 0 is 0. 0 is a number which is less than 2, so this is a true statement. That's true. So because I picked the origin and that was a true statement, that means everything that is within the two green lines, under the red line, but above the blue line, gets shaded in. That is the solution to that system of inequalities.